Hello everyone, it has been a long while since my last video, but that's because I've been working on this behemoth. It's a 16-bit fully functional command block computer in Minecraft. Now, the lack of variables in Minecraft made this very tough, but, I mean, those variables on the side, obviously, but it's very hard to actually integrate them into commands. Anyway, so I have this little program set up for you, which basically just takes these two numbers and multiplies together and puts them out up there. So last test was 4 times 9, we got 36. So I'm gonna quickly initialize the machine. Boop. See the program counter just jump back there. And we're gonna do 4 times 8. Now, we expect 48, right? So I'm just gonna, real quick, start the machine. So it's read, it's reading the inputs right now. So it's just read 4. Yeah, now it's read 8, and now it's gonna multiply them together. So basically what it does is it adds this register to itself twice. It adds the second factor to itself, then stores it to this register, then it decrements this by 2. Then it goes into a loop. First, it checks, is this register 0? If it is, go to the end and put it out there. If not, then add register 3 to register 2, store it back to register 3, and jump back to the beginning of the loop. So that's what it's doing right now. So the next loop will be the last one. So I think we're gonna decrement register 1 quite soon. Yep, there it is. So now here comes the check. Boom, boom, to the end. Store it to that up there. Output up there. And we get... Did I say 48 earlier? I did say 48, didn't I? No. Oh my gosh. No, I did mean 32. I'm not completely stupid. I'm sorry, I've just been working on this for a while. My brain is mush. Anyway, so it's right. 4 times 8 is in fact 32. And yeah, so this computer has a total of, I believe it is 37 opcodes, 38 if you include no op. Here's the book. Yeah, there's no op. You can pause to look at this. Yeah, okay, yeah, 38 including 39 including no op. It has a potential to hold 64, technically 63 because no op. With the 6-bit opcode address, and then there are 2 16-bit numbers that it can address. And yeah, so quick little tour. I didn't show this in the program because it wasn't necessary, but it also has a lot of RAM. It has 4 255 stacks of RAM. There's a little RAM pointer down there, and these are all individually addressable, writable, and readable too, same as the registers. So here it also has 4 flags, 0, negative, and carry, as well as potential for a lot more, up to 16 flags. They're just not assigned. Yeah, 0, carry, and negative. So here is carry and negative, all the flags right here. We also have a ALU that can add, subtract, logical and, logical old, logical not, shift left, and shift right. And yeah, the ALU out, it has its own separate register. It's right here. It gets cloned to up here. Oh, sorry. Up here, ALU out. It's not cloned to a specific register that's done with an op code. So this is where A bus and B bus are cloned to, be read into these are decoders. So this is for adding and subtracting, and this is for the logic operations, and technically. No, it's not. It's not used for the shift because that's just cloning the A bus and moving it, so it never actually goes there. So here is all the commands for that. We also have some important stuff like starting the machine, initializing the variables, which basically just sets everything to 0, teleports the program counter and the RAM counter back to where they belong. And the reset thing, it resets everything. I'm not going to do that because this took a long time to write. And also decode ALU out, which converts a decimal ALU out to a binary ALU out and clones it up there. We also have the jump stuff, which can either A, jump from a register, which is this jump register right here, or it can jump to it from a pre-programmed thing in program memory. We also have conditional jumps, jump if carry, jump if negative, and jump if 0, which also can be jumped from the registers. And it's not as simple as just saying, oh, instruction 19, jump to y coordinate 19, because this isn't at 0, this is actually at 56. So yeah, you got to do a bit of math. That's what those constants on the sides are for. Like 54. All the powers of 10 are used for decoding that 7-segment display over there. I'll show in a second. So we have RAM, where you can write to RAM, which uses a pre-programmed value, or write to RAM, or I'm sorry, where is that? Or you can write to RAM using a value that's stored in this write RAM register right here. Here it is. You can also jump to a location from this register. All of these are copyable to, and when read, the RAM value will go to this register. So yeah, and it was a challenge to make it loop around, but I managed to make that work. That's what 255 over there is for. And these are the opcode decoders. They decode all of the 38 opcodes, like a long line of command blocks. By the way, the reason that it took so long for each individual clock cycle was because of these repeaters. They have to be there because they have to delay the execution of this code until some other command blocks run. But like when I activate them, there's a 4-tick delay, you see, and there's a 4-tick delay again. So yeah, you gotta wait for that. What else do we got? Oh yeah. So over here, this decodes this 7-segment display. So when something is outputted to this IO address, this encoder, it encodes it into the 7-segment display, and then when this is triggered, basically does a bunch of math to figure out how to display the digits properly. So let's just set like /scoreboard set 7-segment. Let's just do 1, 2, 3, 4, 5, right? And I typed it wrong. Wonderful. 1, 2, 3, 4, 5. So we do that, and then we can just trigger this decode 7 segments, and does a bunch of math, and then looky here, we got 1, 2, 3, 4, 5. That was a fun challenge to figure out how to get it to decode that. Lots of command blocks used there, and everything is all nicely labeled. By the way, I forgot to say, this is all vanilla Minecraft, no mods except, world edit, but the world edit isn't actually used in any of the fill commands. Is just to help me build faster, because I'm not gonna place all these by hand. So yeah, so I will include a world download in the description of this video, and for the finale I'm going to reset the machine to show you what that does. So it'll prompt you, are you sure? I'm going to say yes, I'm sure, and then boom, it resets everything, and everything's been initialized. And yeah, so this is the computer I made. So yeah, I hope you all enjoyed this. Bye.